This message is for all the AWS engineers and people who depend on them to make sound choices. There is an insidious evil lying within our designs, a common, even mimetic symbol within our ranks. Everyone sees it and does nothing. It lies. And AWS preys upon your ignorance. Today we break this cycle. Nerds, business people, technicians, and engineers. We must vow to open our eyes and see the demonic presence all around us. Our enemy has spent too much time lying dormant, waiting to strike when our guard was down. Join me in rising up against the casual use of NAT gateways and end AWS's plot to force its bulbous hands into our dwindling wallets.
That seems real dramatic.
Dude, get out of here.
NAT gateways are the default device we use in AWS to get our protected computers access to the internet. If you're not familiar, they do the same job as your home router, only at cloud scale and at a much more expensive price point. Holy shit. If you're following a good design, your VMs are well protected from Hacker Dan and his curious bots with no way for you to get into them. But they need internet access for update, remote control, telemetry, sending stuff to other services. Nothing exciting, totally normal. Except that when you send stuff within AWS, but across boundaries, you usually get dinged about 2 cents per gigabyte. For sending things out to the general internet, it's 9 cents per gigabyte. Pulling things in is free. NAT gateways also have these charges, but they also start at about $35 per month each. They charge you 4.5 cents per gigabyte out, and then another 4.5 cents going in. For a normal development workload, this winds up being like $90 per month. So, chump change really in cloud terms. If you have the right monitoring, alerting, network access policies in place, and review your flow logs regularly, you don't have a lot of risk of too much going wrong. The problem is, statistically, you don't. You literally have none of those things. This is your bandwidth management plan. So when one of those machines downloads malware and decides to spam the crap out of some furry fandom forum to the tune of 40 terabytes of data, you are now on the hook for a $3,700 bill. Heaven forbid you mismanage your S3 access at a similar level, and that bill gets to 6 digits before the decimal point. Let me first point out that NAT gateways have a lot of uses where they should be your first choice. When you lock down your access to known and trusted endpoints, or you have reactive systems in place to prevent problems from getting out of hand, great. NAT gateways scale better and are more reliable than anything you're going to roll on your own. Since the only way to secure outgoing traffic is with security groups and network ACLs, you're going to need IP addresses, and my friends, the internet loves its DNS no matter how naughty it's been. This leaves us with problems that are non-trivial to solve given that AWS does not let us use domain names to block traffic. So the first alternative I'm going to recommend is to set up your own NAT instances. Back in the bad old days before the managed NAT gateways were introduced, you could roll your own, and you still can. Just spin up a public instance running Amazon Linux, make sure you check this box that is basically this is a NAT gateway switch, log in, add a couple lines of code to turn on routing and add it into the route tables, and you're done. If you want to make this sexier, add some traffic shaping, bandwidth limiting, maybe some alerts to restart if the instance flakes out. If you're primarily using this to download stuff from the internet, like updates or whatnot, then this particular setup is good enough for most workloads. It's about $4 a month, and double it for redundancy for $8. If you want to try it, just run the CloudFormation template that I have linked that sets up a budget NAT VPC with bandwidth controls. Check out the template on GitHub if you want to see how it's done internally. The real problem with the previous method is Dan's rule of DevOps number 4. Solutions are a product of their environment. The environment here has open access to the entire internet. It's really hard to limit the scope of what your servers are doing when they can just hit only casefans.com when you're not looking. So in the case where your machine mostly needs HTTPS access, only allow that traffic to a couple of Squid or Nginx proxies and use their config files as layer 7 access controls. This gives you a local cache, which is useful and allows fine-grained control of what the instances behind them can access, while also giving you a diagnostic log of all access that's easy to get to. You can audit the log for new entries and allow deny as you see fit with minimal fuss. If your instances really only need updates and access to other internal systems, your best bet is to give them no access. That's right, just nothing. Set up AWS endpoints to the services you use, most likely SSM, S3, and DynamoDB. Download any patches you need to S3 and use that for updates, and call it a day. Alright, hope you found that informative. As always, I'm Dan, Dedicated Cloud Architect. If you've got anything you want to know about CloudWise, please drop a question in the comments. If you have any ways to improve on what I've said, please, by all means, share. And if I, your humble servant, can do better, please let me know. Thank you, and goodbye, nerds.